Okay, welcome guys. So this video, let's talk about this complex integration, which is similar, but also a little bit strange. So let's start. So cosine ax dx, cosine cosinch, right? Cash hx equals from 0 to infinity. Okay, let's talk about answer. So the answer will be pi divided by 2 cosinch a pi divided by 2. Okay, so our technique will be complex analysis. Okay, so hope you guys subscribe to my channel. And I have another complex video, complex analysis list, which contains a lot of complex integral. So if you are interested, I will post it below. Okay. So consider f of z to be this. Okay. Exponential I z divided by cosinch z. And then let's talk about the integration. So we need to put a contour, right? So let's see, this is z. So I would like to pick contour from like this. Okay, so we start from 0 to at the which is a square, and then let's specify the r minus. So this is r minus r, and there is a pole here, I pi divided by 2. Okay, so remember that the cosinch I pi divided by 2 will be cosine pi divided by 2. So will be 0, right? So there is a pole here. And our height just choose to be pi, I pi, okay? So let's call it A, B, C, D. Okay, so our integration will be A, B, B, C, C, D, D, A, F is 0. And then we will take the limit, let r to infinity. Okay, so let's see the AB. So let's see AB. So AB is a simple one, right? AB will just to be let's see. AB will just to be exponential IAX cosinch x dx from infinity to infinity to negative infinity to infinity. Okay, so let's talk about BC. So BC is a f of z dz. And notice that BC means that your axis r plus iy, right? And the y start from 0 to I pi, so to pi. Okay. So this is also it's not. Oh, sorry, I'm stupid. This is non-zero. It's a 2 pi residue of z equals to I pi divided by 2 f of z. Right? Because if you enclose, there is only one pole here. Okay, so let's see. So this term is let's see, exponential ia. So x, so it's r plus iy. So it's z, right? Z. So it's a cosinch, right? I dy is from 0 to pi. Okay, notice that this term, right? So this is exponential IAR. So exponential IAR is the modulus 1. So this term is exponential IAR times exponential negative AY. So this AY is fixed, right? For fixed Y. So even though from 0 to pi, this exponential AY is just less or equal to 1, right? So that means all these terms, if you take the absolute values, except for this dy, should only have the at most modulus 1. However, there is a cosinch r here, right? So if r goes to infinity, then the cosinch r plus iy will go to 0. Will go to infinity. So it means this BC term will go to 0 as r goes to infinity. So that means we don't need to worry about the BC term, right? So we can just eliminate this. So BC term is 0, right? And by symmetry, so dA term is 0. Okay, so our final term is just this. Just negative infinity to infinity exponential ix cosinch hx dx. This is the first one term. And the second term is CD, right? So CD is here, right? But so let's write down. So CD is the parameterization of CD will be z equals to x plus I pi. And x, right? X still from infinity to negative infinity, and the z equals to x plus I pi. right? Okay, so it's exponential IA x plus I pi cosinch x plus I pi dx. So this term is negative minus a pi, right? So you times this, and negative infinity, so exponential IAX cosinch x plus I pi. So note, let's see. So cosinch x plus I pi is exponential I. Let's see. Cosinch x is defined to be exponential IX plus exponential x divided plus exponential negative x divided by 2, right? So cosinch x plus I pi will be exponential IX plus I pi. Sorry, it's not this. It's exponential x plus I pi plus exponential negative x plus I pi divided by 2. So this is negative 1 cosinch x. So this term is basically exponential negative a pi. So there is a minus term here, right? So I can use this negative term to flip this integration. So I get this. ds here, ds cosinch x. Okay. So combine everything we have. So this is AB. This is a CD, right? CD is here. So total we have we sum of these two, this and this. So we get negative infinity to 0, negative infinity to infinity exponential IAX dx cosinch x 1 minus 1 plus 1 plus, right? Plus exponential negative a pi equals to 2 pi I residue of z equals to I pi divided by 2 of f of z. Okay, so let's talk about residue. So f of z is defined to be exponential IAZ divided by cosinch z. So the only pole comes from z equals to I pi divided by 2, right? So the residue will be just a limit z goes to I pi divided by 2, z minus I pi divided by 2, exponential IAZ divided by cosinch z. So one can use the L'Hopital rule. So if you differentiation respect to z, you get sinh z. And let's see, and this is z I pi divided by 2, and the differentiation is IA exponential IAZ plus z minus I pi divided plus the differentiation in respect to this one, so it's exponential IAZ, and the plug your z approach to I pi divided by 2. So if you plug this, then this term will cancel because this is 0, right? So and the plug z equals to I pi divided by 2. So you get exponential minus pi a divided by 2, and then divided by sinh. So sinh I pi divided by 2, which is I sine pi divided by 2. So which is I, right? I. So this term and the plug in here. Okay, so let's do the final calculation. Let's clean the table. Clean the, yeah. So this term, IAX dx cosinch x will be 2 pi I. Residue of this is 1 over I exponential negative a pi divided by 2 divided 1 plus exponential a pi. Difficult, right? So I cancel. So you get 2 pi in the numerator and the divided this, right? So you get exponential a pi divided by 2 plus exponential negative a pi divided by 2, which is pi divided by exponential a pi divided by 2 plus exponential negative a pi divided by 2, and then there's a half here. So this is pi divided by cosinch a pi divided by 2. Right. So complex analysis calculation is very difficult and hard to. I mean, it's very easy to make a mistake. Okay, but very happily we didn't. So, yeah, we did make a mistake at this part because I write too fast. Okay, so let's summarize the tools, right? So we first choose let's scale, right? So we choose f of z to be exponential iz divided by cosine az, and we plug a square as our contour, and then we prove that. So the first one, AB, will be the correct, right? Negative r, infinity to infinity, and the original one. And we are using the arrow analysis to prove that the BC and the DA must be 0. So the rest are CD, right? The rest are CD. And the CD is also easy to compute. You finally get this. And the sum of them must be 2 pi I of residue of z, I pi divided by 2f of z. Okay, and you get the answer. So yeah, it's a tedious, right? But not so abstract. Okay, so see you guys next video. Hope you guys subscribe to my channel.